Hello and welcome to our next lesson. Today we are looking at saving plans and loans. Our learning goal for today is to be able to use technology and amortization tables to solve problems involving amount, present value, regular payments of ordinary, simple annuities, and we also will look at compound interest as well. So our key vocabulary first, amortization, as used in amortization tables. Amortization is pretty much the process of gradually reducing a debt through regular payments. So consider, for example, mortgage, student loans, or car leases, where you can't necessarily pay for the full amount upfront. So you make regular payments, but while you are making those regular payments, you are earning interest because a specific amount of money was borrowed. So we are going to look at how you can plan to pay those back in terms of the interest and the principal amount. We also will consider down payments. So, especially with mortgage, down payment is a very common term used, which is a partial amount of the total purchase that you make at the time of the purchase. So, let's say you're buying $1 million house. You don't have $1 million right now, but you might have $100,000 in cash or in savings that you can pay upfront as a down payment, which then means that the interest that you earn aren't on the $1 million. They're going to be on the remainder after the down payment is deducted. So in the case of $1 million house, you would only pay or set up your amortization table based on the $900,000 that's left for you to pay. And the learning goal also mentions you will be using technology. So we are using time value of money or TVM solvers. So these are technological tools, and I've included a link for you on Google Classroom as well as over here. And this is just an image of the specific TVM calculator that I've attached for you here. And it pretty much helps us, as you can see at the top, we have future value, we have the present value, and N, which is our period of time, or even interest per year, or PMT, which is the periodic payments, or you might remember it as R, the way we've been using it, our regular payments. So it pretty much is a calculator for any of these values, and how you use it is you set up the values that you do have, and it will calculate the following value shown at the top here. So in this case, it's going to calculate the future value for you based on the number of periods, the interest per year, the present value, and the periodic payments. Now, one thing I'm going to note here that's going to be a little bit different with the TBM calculator, and it might be different based on the one you use, but specifically for this one mentioned here, the IY is the interest per year. So the same, if it's given to you 5% per annum, you will put 5 here, the 5%. And then over here for the settings is where you're going to change for the compounding periods. So one way is that you can just put the number of periods per year. That might be maybe for a more irregular compounding period. Maybe it's like 7 times per year. Or if it's compounded every 4 months, then you can put the number of times interest compounded per year would be 4 times. Or sorry, this one is the number of periods, then you would put that value there. And this is also with regards to annuities that we saw last time. So generally it's at end, which is our ordinary annuities. But if you're making payments at the beginning of the period, then you can change for that over here as well. And so I'm going to show you an example of how you might use this, but you can double check using the calculator for all the examples that you're going to see today. So our first example, we're actually going to see an amortization table, and this one is already set up fully for you, so we're just going to analyze it. So here, Leeway bought a used car for $10,000, and he makes a down payment of $3,500. The car dealer offers to finance the remainder of the purchase with a 1-year loan at 8% compounded monthly. So already here, he has to pay it off in 1 year, and he's making monthly payments. And again, he has paid a $3,500 down payment, which means that the remainder of the value of the car, which because it was $10,000, the remainder is $6,500. Then he has to pay interest on that every month. So In this table here, we have our payment number, our payment amount in dollars. Of that payment amount, it's split up into two sections. One portion is the interest that's paid, and one portion is the principal paid. So the principal is of that $6,500. How much of you are you paying? How much of that are you paying off in each payment? And finally, the outstanding balance. So of course, when the purchase is first made, yes, or perhaps maybe you can consider a payment of $3,500 was made then to account for the $10,000. So now there is $6,500 left. Now, after the first month, he pays, and this is already calculated, and we're going to see later how this is calculated. But for now, take it as he's making payments of $565.42 every month, as you can see over here. Now, of this amount, he pays an interest of 43.33, so $43.33. And if I subtract this from the payment amount, then I have $522.09, which is how much of the principal, so how much of the $6,500 he has paid off. And this part here is pretty much the interest that he earns after 1 month. So consider the 6,500, and now it was 8%, and it's compounded monthly divided by 12. If you calculate this, this is $43.33. And now the next month, he has a balance, or at the end of this month, he has a balance of $5,977.91, which means the next month he actually pays an interest on this amount, which is less. And exactly as we expect, the interest is now less here. The payment has not changed, so the principal paid is actually increasing. And if we now look at the table as a whole, I want you to just analyze, see if you notice any patterns and make any connections. So, as I was mentioning, the interest is clearly decreasing because the outstanding balance is decreasing because you're paying off and you're gradually decreasing your debt. However, the principal paid is increasing because as you have less to pay off, then that means you're paying your regular payments, which don't change, cover less interest and more of your principal amount. And of course, at the end of the year, he has a total balance of zero, which is what we would have expected. And also the total here that I included for you. So especially if you're setting up again with spreadsheets, it is really simple to calculate this instead of a calculator and evaluating this individually. So I am going to erase this for the sake of the total here. But if he makes $565.42 payments every month for 12 months, then at the end of the year, he has paid $6,785.04. And of course, of that, as we would have expected, the principal paid was the outstanding balance at the beginning of the year, which was $6,500. So of that, the interest is $285.04. And I want you to consider how you can calculate this value using what you know about interest and what you've learned so far. So we've already done this analysis, but just to go over it again. So the payments made each month were these values here, so $565.42. How many total payments are made, including the down payment? So of course we have the 12 monthly payments and one down payment at the beginning, so 13 payments in total. And how much total interest was paid to the car dealership, which was this value over here. And it's $285.04 of interest, which for the full year, not a bad value. Again, consider if you don't have $6,500 to pay upfront at the beginning, then you make gradual payments every month and you pay a interest of $285.04 for being allowed to pay every month. So, uh, yes, this one, again, as I mentioned, is an amortization table, and amortization tables are usually set up using spreadsheets with specific formulas. And the reason for that is because they can be easily adjusted. Let's say the next year or for a different car, the values in this table are changed. So let's say you go to the car dealership and you want to play around to know what your monthly payments might be. So you might have the $10,000 and be able to pay it up front, but maybe you don't want to do that. Maybe you want to save your money for something else. So you can ask them, okay, if I pay $1,000 in down payment, how much would I have to pay in interest? If I pay $5,000 in down payment, how much would my interest change? And so all they would do is simply change the values of the balance here, or even perhaps they might have different interest rates based on the compounding period. So maybe you're paying over 2 years instead of 1 year. And if you're paying over 2 years, they give you a higher rate. So then you will be able to do all those calculations by just a change of values. And so it's lot easier of a process than to create this yourself. For the purpose of these next lessons, you will practice setting up a few simple tables. It won't be over long periods of time, of course, but that's why also spreadsheets are helpful, because when we next look at mortgages, then we really don't want to be setting up a monthly payment for a 25, 50-year mortgage. We want to have a spreadsheet do the work for us very quickly. And of course, we use a TVM solver. So you can again practice with the values from the question above with the TVM solver, either the one I've linked here for you or anyone that you can find online that you're more comfortable using, to see that you would get those same values that we got. But the screenshots that I am using for the next questions are using the link that I've attached, which is the same one that I showed you up here. So in our next example, Phoebe has a credit card balance of $10,000 that is charged 23% per annum in interest and is compounded annually. She decides to not use her credit card anymore and to begin making monthly payments to pay off her debt. How long does it take to reduce her credit card balance of $10,000 to $0 if she pays $1,000 a month? So here we actually are solving for n because we're asked how long does it take. We want to know what that period of time is. And we do have the present amount, the PV is $10,000, and the goal is for her to pay off her debt, which means that the future value that we expect is $0 when the debt is paid off. And she's making periodic payments of $1,000, but because it's deducting, we kind of can consider it as minus $1,000. Specifically with the amortization table, if you're setting up the table, you're considering as deductions of $1,000 here from the original debt. And the interest, oh, sorry, so I did think this was an error. This one should be monthly, and that may make sense also because she's making monthly payments. So it is 23% per annum and is compounded monthly, which is also typical rate for credit cards, and they are monthly charges. And one thing to note here as well is that she decides to not use her credit card anymore, which means that the $10,000 is not going to fluctuate. So once she pays off the debt, we're not adding any more as compared to real life, where you might have a $10,000 debt and you pay off a certain amount, but then you still have other payments and you might make payments on that credit card and then the value might be fluctuating. So perhaps maybe if that is the case in real life, you might make all your payments on a separate credit card so you can calculate or have a plan to pay off the debt for this credit card separately from your other credit cards. Now, the 23% per year compounded monthly means that there will be 12 periods per year and the interest will be compounded 12 times per year. So I'm going to show you, yes, I'm going to show you right here. So we are solving for n, which is the number of periods. So the interest per year was 23. Again, remember, we don't do the division here. We just write it as 23 percent. The present value is $10,000, which is what her debt is right now. And the periodic payments, this is why I mentioned the negative here. Because we're paying it off, it is a negative as compared to perhaps you have a $10,000 in your bank account and you're depositing $1,000 to save up more and more. So in this case, because we're paying off, it's negative because eventually we want this 10,000 to become $0. And of course, the period per year is 12, and our interest was compounded monthly, which means 12 times per year. And again, we don't change the n, just leave that one as n. And if you press calculate here, you will get that n is equal to 11.208. And it does show you here as well, the sum of all the periodic payments will be $11,207.66. And of that, $1,207.66 are interest. So considering the 11.208, we can say it might take her approximately 12 months to pay off her debt. And again, you can always round up to account for the debt being fully paid off. Now, again, one reason we have to round up as well is because this is considering accumulated interest as well, which means that after 11.2, but again, we consider the end of the month. So after 12 months, you have paid off more than 10,000, but you at least need the $10,000 because after 11 months, you still have not paid the interest that's accumulated on your original debt, which was the $10,000, which means that your future value or your debt or outstanding balance is still not zero. So then by the end of the 12th month, you may not make a $1,000 payment in the 12th month, but for sure you have paid it off at that point in time. So now, if she increases her monthly payments to $1,600, how much sooner is the debt paid off? So this was really simple. I don't change much of this table. All I do is instead of the periodic payment of minus 1,000, I change it to minus $1,600. And I can clearly see very different results here. First, N is 6.721. And now the sum of all my periodic payments were $10,753.30. And the total interest here is $753.30. So that means the debt here will be paid off, again, if we round up, in 7 months. So 5 months earlier than if she paid $1,000. And that's exactly what we were asked. How much sooner is the debt paid off? By 5 months earlier. And so before I go to the next question, it is the next question, but I want you to consider, why might Phoebe consider paying $1,600 payments every month instead of a $1,000 payment every month? So specifically consider, how much will Phoebe save in finance charges if her payment is $1,600 instead of $1,000? So using the results above, if she's paying $1,000 every month, then the interest that was calculated was $1,207.66. So this one. Whereas if she's paying $1,600 every month, then the total interest was $753.30, which means that the difference in the interest that she has to pay is $454.36. So, of course, she wants to be paying less interest. And of course, in thinking of the real world, maybe she can't do $1,600 payments every month. She can't afford it. All she can afford is $1,000. But this is in the case that she can afford both, but maybe she wants to consider, is it worth it for me to pay more monthly or invest that money somewhere else or do something else with it? So that's, again, something she has to decide based on her finances, but just for us to analyze, we do know that she will pay $454.36 more in interest if she's paying less in monthly payments. And also she's also paying for a longer period of time as well, right? In the case where she's paying $1,000, she's paying over 12 months. And here's the calculation to show you as well. Or if she's paying $1,600 over 6.721 months, then she's also paying over a shorter period of time. And that could also be, if you consider peace of mind, maybe she wants to pay the debt and get it over with. So she'd rather pay more monthly, but then have the debt be paid off instead of thinking about it over a whole year. So, of course, I'm just showing you here that you get the same, approximately the same two values, regardless of if you only look at the interest or if you look at the total monthly, or the total values by the end of the period. So in this case, it was about 11,000. Here was about 10,700. So we see that these two are the same, are approximately the same. So she will save $454.40. Now, in our next example, a $10,000 loan with an interest of 6% per annum is compounded annually over 3 years. And we're asked to compute the annual payment as well as to build the amortization table. So first, using the annuity formula from our last lesson, and we want to solve for the the amount of the regular payments every year. So how much is being paid annually. So we do have the present value of the loan, which is $10,000. So that's why we use the present value formula, but really we are solving for R. So rearranging just from here, R would be equal to P times I and then divide by this numerator here. And so my values here, P of course is $10,000, I is 0.06 from 6%, and N is 3 because it's just compounding annually over 3 years. So then R is going to, by substituting those values in, be equal to $3,741.10. So annual payments are going to be this amount here. Now for the amortization table, this is how your table is set up with regards to the headings here. So always have your payment number because we want to keep track of how many payments have we made. The payment, which is your regular payments. Again, remember these two following columns are the breakdown of this payment. And finally, our outstanding balance, which of course here we are starting with $10,000. So that's what we are starting with, and then we are gradually paying this debt off. So after the first year, a payment of $3,741.10 is made, which means that the payment will go over here. And now, of this $10,000, 6% interest was charged. So $600 of this payment was interest, which means that if we subtract the principal paid, which means how much of this $10,000 we paid was $3,141.10. So of the original payment, $600 of it is just interest that you're paying off, which means that after the first month, your balance of from the $10,000 loan is now $6,858.90. And now you can practice yourself, complete the table for payments number 2 and 3. And this is what you should get over here. So after this second year, so the payments don't change. The payments stay the same every year, but the interest we can see is decreasing because of course our outstanding balance is decreasing. So in the second year, the 6% interest that you pay is now on this $6,858.90, which makes sense now that our interest is less. But then consequently, our principal paid is now more because your payment hasn't changed, but you're just paying less interest on that amount. And so then the principal paid is $3,329.56. And then we have $3,529.34 as our outstanding balance. And of course, we would expect that the following year, uh, that total principal is paid off, which is exactly what we see here. And that's one thing you want to always check out for your amortization table, that the principal paid in the last row is always the same as the outstanding balance in your second last row, which would result in a zero over here. And so, with regards to the TVM calculator or just any of the calculations we've done for um, coming up with this payment amount, this is already accounting for the interest that's being calculated and the balance decreasing, and then that interest decreasing based on that balance. So, all of that is already accounted into when it calculates this payment for us, which is why at the end we get to that zero and it's a perfectly set up table. Theoretically speaking, in our problems, not perhaps in real life, because of course, payments change, and we'll talk a little bit more about that in our next two lessons. But if you use your TVM calculator and you get that payment amount, then you should be able to set up a amortization table with a zero at the end, which means your debt is paid off. And that was our last example for this lesson. So you do have some practice problems here. As always, check Google Classroom for more tasks or reading, and don't hesitate to reach out if you have any questions. And I will see you all in our next class.